The atomic structure is a fundamental concept in chemistry that describes the composition and organization of atoms, the building blocks of matter. Developed through centuries of scientific inquiry, our understanding of atomic structure has evolved, laying the foundation for modern chemistry. The journey to unravel atomic structure began with ancient Greek philosophers who pondered the nature of matter. However, it wasn't until the late 19th and early 20th centuries that significant breakthroughs occurred. John Dalton's atomic theory, 1803, proposed that elements are composed of indivisible particles called atoms. Each element's atoms are identical, and chemical reactions involve the rearrangement of these atoms. The late 19th century saw the discovery of subatomic particles. J.J. Thomson's cathode ray experiments led to the identification of electrons in 1897. Later, Ernest Rutherford's gold foil experiment, 1909, revealed the presence of a positively charged nucleus within the atom. Niels Bohr introduced a model, 1913, where electrons orbit the nucleus in quantized energy levels. This model successfully explained the spectral lines of hydrogen, but faced challenges with more complex atoms. The development of quantum mechanics in the early 20th century revolutionized our understanding of atomic structure. Schrödinger's wave equation described electrons as wave-like entities, introducing the concept of probability distributions for finding electrons in specific regions around the nucleus. Quantum numbers, including principal, azimuthal, magnetic, and spin quantum numbers, provide a mathematical description of electron properties and their distribution in atomic orbitals. The modern atomic model represents electrons as existing within electron clouds, regions where electrons are likely to be found. This model accommodates the inherent uncertainty of electron positions. Within each energy level, sublevels S, P, D, F define the shape of atomic orbitals. Orbitals are regions where electrons are most likely to be found, and they have specific energy levels and shapes. The Pauli exclusion principle states that no two electrons in an atom can have the same set of quantum numbers, while Hund's rule dictates that electrons fill orbitals singly before pairing up. The arrangement of elements in the periodic table is based on atomic number, which is determined by the number of protons in an atom's nucleus. The periodic table provides a systematic way to organize and understand the properties of elements. And that concludes our brief overview of atomic structure.